Okay, so we have been spending some time in this, I guess you would call it a inverse unit. We talked about inverses, and what's the key to an inverse? Flip the x and y, solve for the y, correct? And then we started looking at some nonlinear ones. Yeah, and y'all were still like, hey, that's not that bad. Well, today is kind of a bridge between that and some old stuff that we have been doing. Yes, old stuff. I'm going to start by giving you this expression. Yeah. Now, each part of this represents something. Transformationally, where is that A? It's out in front, so that's going to mean it is what? Vertical, stretch, or compress. What about that 1 over B? It's inside, so it's going to be a horizontal stretch or compress. Why did they go to the effort to write 1 over B? Why did they not just write B? Because inside is always opposite. Very good. What about x minus h? What does the minus h mean? So that's my left or right movement. Always the opposite sign. That's why in this formula they always give me the negative sign. And what's the plus k? Up or down movement, right? Very good. So you guys remember this from a long, long time ago, right? Good. That makes this next slide easy. Describe the transformations of g of x from the parent function f of x equals the square root of x. So let's look at this first one, the one on the left. G of x equals the square root of 1/2 x plus 1. Now, it's inside, so we recognize it is horizontal. Yes? Because it is 1/2, we're going to take the opposite, so it is a horizontal what? What does that plus 1 mean? Fresh for most of you? I see most of your faces. Most of you really do feel like, hey, okay, let's do it. What about the second option over there? It's a reflection. Why is it a reflection? Woo! So reflect over x because of that negative. What would a reflect over y look like? Inside. It would be inside. Very good. So what does that 5 do? And it goes left 1 and down 3. So there's a big chunk of those that you're going to get on your homework. I hope for most of you, hey, that's not going to be too bad. Because that really is a review, right? Like we did it the first time, and you're like, oh, this is so hard. And I was like, well, I'm going to go fast because we're going to do it again. And then we did it again with a different kind of function. And then we did it again with another kind of function. Well, guess what? Here we are doing it again with another kind of function. And guess what we're going to do tomorrow? We're going to do it again with another kind of function. No. Another one. Now, more review. We also have to describe the domain range using each of the functions in set notation. Now, the domain and range. When we were talking about functions and it was a polynomial, the domain was all real numbers, right? And we could do that for everything that was odd. When it was even, we had to restrict, yes? What about the range? Same concept? Odd numbers were all real numbers. Even powers we had to restrict. Same kind of concept here. Because this is a square root, there's going to be some restriction. Make sense? What do we know about square roots? Okay, but what can we not do with square roots? Can't have a negative inside. Right? Why not? Because it'd be imaginary. So if I were thinking about the domain, how would I specify this is the ones that we can't have? So I'm going to take everything under the square root. I'm going to do this one time and show you. Then I'm going to do it another way, and you'll feel better. I'm taking everything out from underneath the square root, and I'm going to set it greater than or equal to 0. Why? Because whatever's under there has to be positive, right? So I'll multiply this side by 3. 0 times 3, we like that. So there's my domain. Now, Keaton, you're a pretty smart guy. What's the transformation of this function? But you do know. Yeah, what's the shift?
Are you talking about like the new one? Or?
Just the transformation of the function at the top.
Oh, you go right one.
So I'm going to go right one. What happened to the domain? Go ahead and say it, yeah. It also went right one, didn't it? So couldn't I use the transformations to help me identify the domain? Smart. What happened to the range here? Did it go up or down any? So what am I going to say about the range? Because there was no up or down movement. How can I write those in set notation? Do you remember what the set notation looked like? There's my domain and range in set notation. Now, a couple of you really picked up what I was doing there, but a couple of you are still behind. So I'm still going to take what's under the square root. So in my second function, what's underneath the square root? Nothing else matters, does it? Because what's under the square root is what has to be positive. Transformationally, how can I arrive at that conclusion? Well, didn't I take the function left 4? So I'm going to take my domain and I'm going to say, hey, let's move it left 4 as well. Using that logic, how can I find my range? So let's put it in set notation. It went up 3. Yeah. Up or down, we don't change signs. Left or right, we do. The only place you're going to have some trouble here, and I've been teaching long enough to know this is a trap that you guys fall for. What happens if I gave you a problem that looked like this? Let's say y equals -2, the absolute value, x plus 3 minus 4. What's the domain? What's the range? Y is? You all fell for it.
Is it 8?
What's the reflection do? It's going to turn it upside down. So what am I going to do to my range? Da-da-da-da. You did after a minute. Took you a while.
So like what?
Yes. -3, yes. Good save.
Wait, so.
Well, I'm just going fast.
Is it, it's a K?
Those reflections can have effects on domain and range. You understand that?
Is it?
What are you doing with,
I'll absolutely do one with a reflect over the Y. So my domain is -1, but notice how it's negative on the inside. So that's going to flip it over the y-axis. So all of my x values are now on the left side. Does that make sense now? What about my range? I don't think that's the worst. The domain is actually pretty easy. You just have to pay attention to those reflections. Fair enough? All right, we're continuing our review parade here. Remember when we had questions that looked like this? You do remember that? Oh, sort of. Except they were for quadratics. Or it gave me the quadratic and it gave me the general form of the equation and I had to plug in stuff. It's almost like I did this before. It gives me 2 points. There's one of them that is a very, very important point. The other one is just a regular old point. The starting point, right? That starting point represents which 2 letters? Because transformationally, isn't that where I move that starting point, right? Oh, it's like these transformations work together and make everything easy for me when I really understand them. So what do I plug in for HK here?
X plus 1.
Or what is H and K first?
-1. -5.
-1, -5. Kind of acts like a vertex, right? What do those other points represent? Or just any old X and Y. That one is the Y-intercept. It works out nice, but in general, it's just X and Y. What's the X value? What's the Y? So I have identified H, K, X, and Y. Well, what is A? That's what we don't know, right? So I'm going to show you how to solve for this. I'm going to plug in all of these pieces. G of X is the same thing as Y. So -2 equals. I have no idea what A is. X is 0. Minus -1 is +1. And -5. So if I want to solve for A, add 5. Very good. What's 0 plus 1? What's the square root of 1? What's 1 times A? I have now found what A is. Can I write my equation for that? So old G of X, man. 3 X plus 1. Because remember, we're keeping our X and our Y. Minus 5. Pretty much, yeah. You don't like it? Oh, not so bad.
It's a little hard.
A couple of you still remember that I taught you this way back when. Where is that 3 in the position of? It's a stretch or compress, so can't we read it like a slope for the first reference point? Watch this. If it has a 3, what's that slope? 1, 2, 3 over 1. Now remember, I can't do that for any other points, just that first reference point,
Can
right?
you do that on every one like that?
For the most part, yeah, if you know what you're doing. They get a little fuzzy sometimes, though. Like this next one. It gets a little fuzzy.
Oh, yay.
Why is this one a little bit different? It's a horizontal stretcher compress, so something strange has happened. Kind of makes sense? Yeah. So I can't just look at it and say, oh, the slope, and put that where A is, because we're not finding A, we're finding 1 over B. Do I still do things the same way? What is my Y value? Well, I'll try to make it bigger for you. So it looks like it went right 1/2 up 2. So two equals square root 1 over B. What was my X again? 1/2. Now, what's this H and K? So it's right 1, up 1. So I'm subtracting 1 over. I like that. What's 1/2 minus 1?
Negative 1/2.
Oh man, I love it. Now, what's the issue here? I could, but something else is in the way. That square root's kind of stopping me from doing some stuff, right? But we've been working on our inverse functions here for a while. So when I square a square root, they cancel each other out, right? But because it's math, I still have to do it over there too. So 1 equals 1 over B. Now I can multiply by 2, but I don't want to just take 2. I want to bring negative with it. Wouldn't that cancel that? So then I multiply over here by negative 2. So this is kind of a tricky step because some of you are clever enough that you can do this, but some of you have to physically solve for B. Does that make sense? I'm going to do both just because I want you to see both. So I multiply by B to get it off the bottom, right? And then I would divide by negative 2 to get B by itself. So B equals negative 1/2. You on board with that? But I also have this statement. And the reason I'm showing you both is because, well, you guys probably need to see both. Some of you need to physically find B to plug in. Some of you can recognize, hey, that's 1 over B, so I can just replace that whole statement 1 over B with negative 2. You see, yeah. But some of you actually physically have to find B to plug it in.
If B, if your answer was 6 instead of -2, could you just do -6 equals 1 over 2?
Because when I plug in B, wouldn't it be 1 over negative 1 over 2? Which is actually what? Negative 2. So it's just adding extra steps. I don't care which way you do it. You just need to be able to find B and get to your equation. Now, let's write my equation. So g of x equals, what reflection is happening here? It's over the y, so that's why it's a negative 2 in there. Does that make sense? Square root of -2 x minus 1 plus 1. Now, Tobias, if I had to say, hey, what's the slope here, what would you tell me? So couldn't I say up to over 1 to get to that first reference point? So if you know what you're doing, you can kind of manipulate that concept to check your work. I would not rely on that concept to find the answer, but it is pretty good for, hey, does it look like it's supposed to be there? Does that make sense? For finding your answer, probably not. For checking your answer, absolutely. Any other questions? I said basically the whole day was review of old stuff with a new function. Your homework is on HRW. It is about 18 problems, but most of it's transformations. There's a lot of click and drag. There's a lot of drop-down menus, so I tried to do you some favors. If you guys get through that, you have any other work to work on, it would be a good chance.